Hi. So let's talk about the oxidation state for sulfur and other stuffs. So welcome to Cashew Academy. So in our company, we are trying to give a lot of technical information for free of cost via YouTube channel. The name is Cashew Academy. Let's move on. So oxidation state, this is one of the very important question they are asking in many exams. That's why I'm putting it here. Over here, you're able to see for sulfur, S2OH, 2 minus, it got an oxidation state of +7. SO4, 2 minus, it got an oxidation state of +6. S2O6, 2 minus, it got an oxidation state of +5. And SO2 got an oxidation state of +4. S2O3, 2 minus, got an oxidation state of +2. And the pure sulfur or SH got an oxidation state of 0, and H2S hydrogen sulfide got an oxidation state of -2. So these are the oxidation state of sulfur. So it's one of the very important one, just make a note of it. Now let's talk about the same thing with the oxidation state of chromium. So this is also a very important question they will ask. So all these compounds are +6 oxidation state, and all these compounds are of +3 oxidation state, and this compound is of +2 oxidation state. So it's a chromate, CrO4, 2 minus. It got an yellow color and it got an oxidation state of +6. Cr2O7, 2 minus, it got an oxidation state of +6 with the color of orange. And over here we got a bit more complex compounds like CrOH6, 3 minus, it got an oxidation state of +3 with the green color. Over here it's a bit more complex, CrH2O3OH3, it got an oxidation state of +3 with a green color. On the other end you got some other compounds like over here you're able to see the compound CrH2O6, 3 plus. It got a color of a violet and maybe a ruby color. Okay. On the other end we got another compound with ammonia, CrNH3, 3 plus. The color is purple. On the other end, we got one compound with the oxidation state of +2, that's a CrH2O6, 2 plus. If it is 3 plus, it's a violet. If it is 2 plus, it's blue in color. So these are all some of the very important questions they may ask in many of the exams. Just make a note of it. Okay, let's move on to an interesting question which they asked in AIEE 2010. So let's see the question. So the question is, 3 reactions involving H2PO4 are given below, 1, 2 and 3. Okay, so I want to find which is the best and the exact reaction. So that's the one we need to identify. Let's move on. Over here in this equation, H2PO4, it's nothing but a proton donor. It should give an electron or proton to others. Okay, over here I'll take the third one, H2PO4 minus. It becomes H2PO4. It indicates it gains an electron, it didn't lose the electron. So this is not the case, no. Over here H2PO4 became a product. So it didn't gain or it didn't lose an electron. So proton donor, no. This one is not an answer. Maybe option B can be an answer. Let's see. Over here, I got O4 minus. H2 PO4 minus become H2 PO4 2 minus. It loses an electron or proton donor. So obviously the answer should be the second one. Option B is an answer. So let's move on to an interesting area, that's your halogens. So halogens, like what do you mean by halogens? It's nothing but salt formers. If it join with someone, it will become a salt. That's why it's called a salt formers. So four things we need to identify in halogen. So these are all the elements available, and if it reacts with a boron or something like that, it will become a Lewis acid. Let's see those things later. And these are the 5 elements of halogen. So fluorine, chlorine, bromine, iodine and At. So we got 5 elements as halogens, salt formers. Let's see the question. The question is the tendency of BF3, so boron mixed with the fluorine, BF3, BCl3 and BBr3, so fluorine, chlorine and bromine, to behave as a Lewis acid decreases in the sequence. This is the question. They gave 4 options to me. Now, this is the reaction. In this reaction, you should understand one thing. What is Lewis acid? Lewis acid is nothing but an electron pair acceptor. So I should accept an electron, I'll become a Lewis acid. If I give an electron to someone, it will become Lewis base. Acid, base, Lewis base. Okay, so if it combines, it becomes a compound, a complex compound. Okay, so as the question indicates, Lewis acid decreases, we need to identify. If the halogen atom increases, the acidic strength of the boron halide increases. So indicates fluorine is the lowest one, chlorine is the next one, bromine, iodine, and you'll be having this At. Indicates fluorine is the lowest one. So here we got this symbol indicates this symbol. So this should be here, followed by maybe chlorine, followed by maybe bromine. So we have to see like that. Now let's see. Bromine is here, and this should be here and this should be here. No, this is not an answer. Bromine should be here and followed by, so here the greater symbol is here. So bromine should be here and chlorine should be here. No, this is not an answer. Okay, so option B can't be an answer. Now let's move on. Chlorine. Chlorine is here followed by bromine, yes, but we got bromine here, which should be here. Which should be here? No, option C is not an answer. So let's see whether we got anything a different one. So from our example, A is not an answer, B is not an answer, C is not an answer. So obviously D should be an answer. Let's see. So fluorine, yes. Followed by chlorine, yes. Followed by bromine, yes. So obviously the answer should be option D on the oxidation state. This one is interesting, where I'm going to talk about the boron group. So boron is nothing but it got the elements as boron followed by aluminium, gallium, indium and thallium. So these are the 5 elements available. Among the 5 elements, 4 elements are considered as metals, and the one thing boron, it's metalloid. This is one of the very important questions they will ask in the interview, so well prepare it. On the other end, we should understand what is inert pair effect. So boron will have, this group will have an inert pair effect if it mixes with transition metals or compounds. What about inert pair effect? It's nothing but they got the electrons in the outer orbit, and these electrons are not interested to share the electrons to form a compound. That's why they call it as inert pair effect. So inert pair effect is nothing but the tendency of two electrons in the outermost atomic s orbital to remain unionized or unshared in compounds. That's why they called it as inert pair effect. Over here, let's move on to the boron. So boron got the oxidation state is +3, aluminium it's +3, gallium, indium, thallium, they got the oxidation state as +1 and +3. Now, this is how I'm going to tally it. So over here we got the stability, the oxidation state increases on moving down a group due to inert pair effect. So oxidation state will get increases. So obviously, so thallium will have more oxidation state increases, and followed by indium, followed by gallium, followed by aluminium, followed by boron. So it got the highest one and it got the lowest one. So I got my, you can see it here, this is the highest one, right? Over here you got aluminium. No, this is not an answer. This is not an answer. Now I got the thallium here. Okay, thallium here. Okay, it can be this one or can be this one. So the option can be between these two, either this one or this one. Now let's talk about this one. Thallium, yes. Followed by aluminium here, no. Followed by indium, no. This is not an answer. It can't be an answer. Let's move on to, so this can't be an answer. Let's move on to the final option over here. Thallium, yes. Indium, yes. Gallium, yes. Aluminium, yes. Option A is the answer. So thanks for watching this video, and we got almost 20,000 videos with all explanation in both in Tamil and also in English. So you can subscribe to our YouTube channel Kashu Academy to get latest updates. Thanks for watching. Thank you.